Welcome to the San Jose Convention Center for the highlights of NVIDIA GTC 2026. On March 16, 2026, CEO Jensen Huang took the stage to launch a global shift in computing. We have officially entered the industrial revolution of intelligence. Let's break down the breakthroughs that are reshaping our world. We have reached an inflection point. Since 2025, inference demand has skyrocketed, driving data center revenue from $0.5 trillion to over $1 trillion in 2027. This isn't just about training anymore. It's about the massive scale of daily interaction. 40% of this growth is now coming from sovereign AI and industrial enterprises, as every region on Earth builds its own intelligence. Introducing the new Inference King. Compared to the H200, the GB300 NVL72 offers 50 times higher performance per watt. This is the result of extreme co-design. We didn't just build a chip, we built the entire rack to be an inference engine. When you lower the cost of a token by 35 times, you unlock applications that were previously impossible. AI factories are the industrial infrastructure of our era. In this new world, inference is the workload, and tokens are the new commodity. Compute is no longer just an expense, it is revenue. We are building the assembly lines of intelligence, where every watt put in produces valuable tokens out. To power these factories, we need a new fleet. Here is the Vera Rubin architecture. From the Rubin GPU and Vera CPU, to the CX9 and Bluefield 4 DPU, and now including the Grok 3 LPU for ultra-fast inference. This is a unified family of processors designed to work as one massive, liquid-cooled computer. Performance is a curve. As models like GPT-MOE reach the 2 trillion parameter scale, the need for interactivity, tokens per second per user, becomes critical. Rubin NVL72 shifts the entire curve upward, delivering 2 to 10 times throughput across free, medium, and premium service tiers compared to Blackwell. Efficiency directly translates to profit. By increasing revenue per gigawatt by 5 times over the Blackwell generation, Vera Rubin unlocks a $150 billion revenue opportunity for service providers. This isn't just a technical upgrade. It's the most significant economic engine in the history of computing. When we combine the throughput of Rubin with the ultra-low latency of the Grok LPX, we achieve something miraculous. At high interactivity levels, we see a 35 times performance boost over Hopper. This allows for thinking models that can reason in real time, providing immediate, high-quality responses. We are pushing the boundaries to 1,000 plus tokens per second per user. In the Ultra tier, where reasoning is deep and complex, the Rubin plus LPX combination maintains high throughput where others fall off. This is the hardware required for the next generation of autonomous agents. The total annual revenue opportunity doubles when we integrate LPX into the Rubin architecture. We are looking at a $300 billion frontier. By delivering 10 times the revenue capacity of previous generations, we are enabling the business models of the next decade. Let's look at the silicon. The Rubin GPU features 336 billion transistors and 288 gigabytes of HBM4 memory, delivering 50 petaflops of NVFP4 power. Alongside it, the Grok 3 LPU provides 500 megabytes of on-chip SRAM, with a staggering 150 terabytes per second bandwidth. Together, they unite the processors of extreme performance. Architecture matters. Our NVIDIA Dynamo system splits the workload. Rubin handles the massive prefill stage, while the Grok LPX takes over the decode stage. This coordination ensures the first token is instant, and the remaining tokens flow like water, maximizing the utilization of the KV cache. This is the Grok 3 LPX tray. Available in the second half of 2026, it packs 8 LPUs, 315 petaflops of compute, and 40 petabytes per second of memory bandwidth. It's designed to scale up to 256 chips in a single coherent domain via C2C links, providing the decode muscle for the Rubin factory. Let's compare. A 1 gigawatt AI factory built on Vera Rubin delivers 16 zettaflops of AI power. That's over 13 times more than an x86 Plus Hopper setup. We've increased memory bandwidth per domain by 50 times, and tokens per second by 350 times. This is the leap from a data center to a superpower. We are committed to an annual cadence. 2024 was Blackwell, 2026 is Rubin, and in 2028, we will introduce Feynman. Every year, we will deliver an X factor in performance, die stacking, and custom HBM to ensure the industry can keep up with the demands of AI. Building an AI factory is complex. The NVIDIA DSX platform provides the reference designs, libraries, and software APIs needed to scale from chips to facilities. With DSX Flex and Omniverse blueprints, we allow you to simulate and optimize the power and liquid cooling of your entire infrastructure. Intelligence has no limits. Today, we announce NVIDIA Space One, This is a Vera Rubin module specifically hardened for orbital data centers. We are taking the world's most powerful AI to the stars, enabling autonomous satellite constellations and real-time planetary scale processing. Software is evolving. Look at the star history for OpenClaw. It is growing faster than React or Linux ever did. We have reached an inference inflection, where the world is moving toward open, agentic frameworks. NVIDIA is proud to be the foundation for this movement. Agents are the next great computing platform. An agent isn't just a model. It's a system with memory, computer use capabilities, and a set of skills. It uses tools, interacts with files, and employs sub-agents to complete complex tasks. This is how the world will interact with computers moving forward. We are witnessing an enterprise IT renaissance. We are moving from the era of SaaS, software as a service, to agent as a service. Instead of information workers spending hours in software, agents will perform the work, turning data centers into token-producing factories for the enterprise. To accelerate this, we are announcing NVIDIA NemoClaw. It's a reference implementation of OpenClaw, part of our NVIDIA Agent Toolkit. It includes everything, Nemo, Dynamo, and NIM, to build specialized agents that can use tools and reasoning to solve enterprise problems. NVIDIA is now the world's largest contributor to open-source AI. From BioNemo for biology and Earth-2 for climate, to Groot for robotics and Cosmos for physical AI, we are open-sourcing the foundation models that will define the next decade of innovation. Nematron 3 Super is now the best open model for OpenClaw. It matches or beats the most powerful proprietary models in the world, including Claude 4.6 and GPT 5.4 in reasoning and planning tasks. We are giving the community the most powerful brain for their agents. Nematron 3 Ultra isn't just accurate, it's efficient. It delivers 5 times the peak throughput on our GB200 systems, while maintaining the highest reasoning accuracy across coding, math, and multilingual benchmarks. It is the gold standard for base models. The world is building regional AI. From Wide Labs in Brazil to Naver in Korea and TII in the UAE, nations are using Nematron to build intelligence that reflects their own culture, language, and values. NVIDIA is providing the engine for this global sovereignty. The ecosystem is vast. Giants like Adobe, SAP, Siemens, and Salesforce are all building on the NVIDIA Agentic stack. Thousands of startups and partners are now using our NIMs and libraries to transform every industry, from creative arts to industrial manufacturing. From healthcare with Abridge to finance with MasterCard and PayPal, and industrial automation with Rockwell and Schneider Electric, every vertical is being reinvented by agents. The era of agentic AI is here, and it is powered by NVIDIA. Thank you.
We've just seen the powerful vision presented in the keynote. Now let's analyze the architectural shift of this industrial revolution. NVIDIA is evolving beyond its role as a chip manufacturer to become a provider of integrated global AI infrastructure. This transition reflects a mandatory shift in how modern enterprises must scale, moving from general-purpose computing to a specialized intelligence utility model. CEO Jensen Huang characterizes computing as a new industrial commodity, and the data supports this. By adopting a strict annual hardware cadence, NVIDIA is significantly accelerating the industry's innovation ceiling. While this rapid pace demands consistent investment and a cycle of regular infrastructure updates, it also provides the necessary performance leaps to make the token economy commercially viable for global enterprises. The transition from a cost-centered to an intelligence refinery represents a strategic evolution of the data center. IT infrastructure is being redefined as an active production line for intelligence. While this model requires high capital intensity and advanced liquid-cooled environments, it effectively lowers the barrier for generating high-quality AI outputs at scale, though it favors large-scale players capable of maintaining such specialized refineries. Technically, the engineering feat is remarkable: 336 billion transistors on a 3-nanometer process. This level of full-stack integration is a strategic choice to maximize performance through vertical co-design. While this creates a highly optimized environment that offers unmatched efficiency, it also results in a deeply integrated ecosystem, making the provider's infrastructure a core, long-term component of a company's technology stack. NVIDIA has assigned clear, specialized roles to its silicon lineup: Rubin for high-capacity training, Vera for orchestrating reasoning, and Grok for high-speed inference. The integration of Grok technology allows for a significant reduction in token costs. This specialized fabric ensures that the entire lifecycle of an AI token is optimized for speed and cost-effectiveness, setting a high benchmark for inference performance. The new mantra, "The rack is the new unit of compute," addresses the scaling needs of modern AI. By utilizing NVLink 6 and BlueField 4, NVIDIA is transforming the data center into a modular system of $3 million building blocks. This shift commoditizes the rack level, offering high-performance density while simultaneously redefining the role of traditional server OEMs within a standardized infrastructure blueprint. The industry is moving from the age of copilots to the age of agents. This transition marks a leap toward higher productivity through total automation. With the shift toward agentic software, the layer of human-AI collaboration is evolving. NVIDIA's OpenClaw aims to provide a standardized agent OS, creating a consistent environment for how these autonomous systems interface with digital tools. This diagram illustrates the agentic swarm in operation. A Nematron 3-powered lead agent coordinates specialized sub-agents across developer, legal, and marketing domains to execute a complex product launch. Each agent utilizes chain-of-thought reasoning to iterate and verify its output independently, allowing the entire system to self-correct and complete high-level objectives through distributed autonomous logic. Cosmos and Isaac GR00T function as the translation layer between digital intelligence and physical action. By standardizing physics simulations in a virtual one-shot learning matrix, NVIDIA is providing a foundational framework for robotics. This ensures that autonomous machines can navigate real-world variables like gravity and friction through a unified, pre-trained physical intelligence model. This slide explains the role of global automotive fleets as distributed data collectors for the AI factory. Partners including Mercedes-Benz, Hyundai, and BYD are utilizing their vehicles as mobile nodes that beam physical edge data back to a central Rubin factory. This architecture allows for the real-time updating of global driving models, where the data gathered from millions of miles driven is refined and redeployed to enhance the entire fleet's capabilities. NVIDIA is extending computational limits into orbital and biological frontiers. Orbital data centers aim to solve terrestrial data constraints, while BioNeMo Proteina Complexa simulates biological logic to accelerate drug discovery. These efforts position high-performance computing as a central pillar of the pharmaceutical and aerospace industries, potentially cutting development timelines from years to weeks. NVIDIA is establishing new hardware infrastructure standards to address the critical challenge of thermal management in next-generation computing. To handle high-power density environments that exceed the limits of traditional air cooling, a 100% liquid-cooled system has been adopted as the default specification. This shift enables a 25 times increase in computational density per square foot compared to previous generations. The advancement in hardware architecture marks a technical turning point, where data center design standards are being redefined toward precision liquid-based infrastructure. NVIDIA proposes a model where data centers serve as flexible batteries for the energy grid. This is a strategic attempt to integrate large-scale compute with global energy management. By using DSX Flex to balance renewable energy supply with training workloads, AI factories can function as grid-stabilizing assets, potentially transforming compute power into a constructive component of the global energy infrastructure. Ultimately, the Woodstock branding signifies a complete transition from a component manufacturer to a provider of full-stack AI infrastructure. While NVIDIA offers an integrated system of physical, digital, and energetic logic that promises to accelerate human progress, this centralized roadmap also raises important questions about industry-wide dependency. As the production of intelligence becomes highly efficient and integrated, the challenge for the next century of computing will be balancing this unprecedented scale with the need for a resilient and diverse global technological ecosystem.